Hello, I'm Stefan Greber, project leader for LXD, and in this video we're going to be going over running LXD in a production environment. So, in most of the videos so far, except maybe for some of the larger scale clustering ones, it's usually been showed how to run LXD on either your own laptop, on desktop machine, or on some random spare system or cloud instance. Now, if you're going to be running LXD for an extended period of time, especially if also running this as a cluster, there are a few things you want to keep in mind and a few things that needs to be tweaked to provide a safe, reliable environment. And well, this is what we're going to be going through today. So, kind of from the start, one of the main things you're going to have to decide is what version of LXD you want to run. LXD has LTS releases. Those LTS releases, which stand for long-term support, are released every 2 years and are supported for 5. We only provide bug fixes on the most recent one of those. So if you're gonna go down the LTS route, you're probably gonna want the latest LTS, which right now would be LXD 5.0. In general, for production environments, the only reason not to go with an LTS is if you absolutely need a feature that has been released since that latest LTS. We don't backport features to our LTS releases. So if something was added that you absolutely need for your environment in, say, LXD 5.1, 5.2, or 5.3, well, then you're going to have to run the latest version of LXD, which means a monthly update cycle. If you don't need any of those features, then you should definitely be running the LTS release instead. Now, there's a few different ways to get that. It mostly depends on how you're installing LXD. Some distributions have native packages. Some of those distributions then have decided to package our LTS release. Some other distributions instead decide to package the regular releases. We generally recommend Linux distros package the LTS because most Linux distributions have a reasonably long turnaround for packages, so having to deal with monthly releases from our side is not really the easiest, and it would be better for them to do LTS, but it's not always the case. Now, if you have the options through your distro, then again, based on what features you need, pick whether you want LTS or playtest. If you're a Snap user, well, conveniently, you've got access to every single LXD release. So you can pick 3.0, 4.0, 5.0, or the latest release of LXD. Now, we do have a separate post here, which is specifically on how to manage the LXD snap, which goes over some of that. It goes over our track and channel structure. For production, you always want to run a stable channel. You never want to run candidate or beta or edge. Those are just not a risk you want to take in production. And then the track is what you would decide. So if you need to have the latest LXD and will deal with the monthly release upgrades, then you can use latest. Otherwise, you can use 5.0. The other thing that's worth noting here, and it's the next point in that article, is that if you are going down the latest route, you don't necessarily need to have, well, you can still pick what release of LXD you want. So right now you could say use the 5.6/stable channel, and that will get you the 5.6 updates until 5.7 is released, at which point you're going to be stuck on whatever the latest build of 5.6 was. And it would be up to you to then do a refresh onto 5.7 whenever it's convenient for you. So there's that option, which does limit some of the amount of risk if you do need to use the latest release. You won't have an automatic update to the next major release of LXD. It will be up to you to do it when convenient. But please remember to do it, because if you use those monthly releases, we don't support the previous release. You need to be on the latest one if you want to have any chance at reporting bugs or security issues or anything to us. Alright, there's some more tweaks you can do around the snap, like setting refresh windows, which you should be setting to a time where you don't mind LXD going away for potentially a minute or so to restart if there's a security update or a bug fix update or something like that needs to be applied. So you can set that either to whatever maintenance window you might already have, or to a time that is not going to disrupt anything. And then there's some more details around how you can even get more specific around specific releases and everything. And for those running LXD at large scale and using the snap, the recommendation would be to use the snap store proxy, which then lets you pin very specific revisions and do effectively your own testing. And once it's good, then release that revision to all of your systems. All right. So that's the snap side of things as far as deploying things. Then you've got the host system configuration. There, I mean, some of it, some of it is kind of related to LXD, some of it not so much, but basically you'll want your host to be kept up to date. You should always apply your security updates. You should definitely take a very close look at any kind of kernel update, because if you're running containers, kernel updates are a very, very big deal. You really want those security updates applied very quickly. You can use live patching if your Linux distributions offers it and releases their patches in a timely manner. There's really no point in using a distro's live patches if they're gonna take months before you get a fix. That's way too late for a container hosting platform. You should just reboot at that point, which is not great for anything running on your system, but that's really the only way to stay safe. Then there are a few tweaks you need to make, that you probably will want to make, and they are described here. There's also a comment that's listed for those that do not apply to the snap. So that first chunk is only relevant if you're using native packages on your distro, but effectively what it means is that it raises the basic limits to something pretty high, so that LXD doesn't get artificially capped to a number of open files or number of amount of memory being locked, which would then be propagated to containers and cause issues down the line to them. The other thing that you will most likely want to apply, and this is not necessarily security relevant necessarily, some of the settings are, like the demessage restrict one, for example. The bulk of those are actually about scalability. Because if you're running containers specifically, and most of those actually apply primarily to containers, not so much virtual machines, all the containers still share the same kernel, and there are global resources on your system which are set to a sane amount for a single system, but not so much for potentially hundreds of Linux systems running on the same kernel. So some stuff needs to be increased. This includes things like the async IO number of instances. If you're running databases in your containers, the default amount is not going to be enough. You're going to run out of that very quickly. So we want to bump that. Similarly with iNotify, if you're going to be using systemd in your containers, which most Linux distributions are using, you want to bump that. Otherwise, you're going to usually run out of iNotify handles at about anywhere from like 20 to 50 containers, at which point it's going to look really weird. The container will only partly start and some services will just hang, and it's going to be very hard to debug, but that's the source of the issue. So those do need to be bumped. Demessage restrict, these days most Linux distributions actually have it set to something reasonable. But it used to be that a bunch of distributions did not prevent access to demessage, so your containers could access the kernel log and could get a lot of information about whatever else is running on the system, which they don't really need and could potentially be used to attack other containers. Then we've got kind of similar, and that's also a systemd thing, I believe, the kernel keyring. That's getting more and more used by variety of applications, and again the defaults are a bit low and you're gonna be just running out of those pretty quickly. So if you're gonna be running more than, I don't know, anywhere from like 20 to 50 containers, if you're running more than that, you definitely want to bump those. And the values we suggest there are usually reasonable for like up to a few hundred containers. If you go way past that, you're probably gonna need to bump things even further. Then we've got the networking stack, where effectively the kernel needs to keep track of, on IPv4 that would be ARP, on IPv6 it's neighborhood entries. There's effectively, there's gonna be a lot of active MAC addresses on the bridges within LXD, and we need the kernel needs to keep track of those. If those values are set too low, so the default is 1024, but that doesn't just include the LXD bridge, that also includes all other interfaces on the system. If the value is too low, then there won't be enough entries to keep track of all the instances running on the system. And what will happen is that you're literally not going to be able to ping or to maintain any kind of network connection with some of those instances. It's mostly an issue if they're all actively doing stuff, but still, you should be bumping that if you expect to have a few hundred instances or up to 1,000 instances or something like that. You're gonna want to bump this. And the last one is around the number of memory maps that can be run within the system. Similarly, if you're running a lot of processes that make use of those kind of calls, you need to bump that as well. The vast majority of those, there's really no real issue in bumping them. They tend to have a reasonably low limit, mostly to avoid accidents on the system. It's like just a safety net, effectively, that the kernel has. Some others do effectively need some amount of memory. So increasing them will increase the kernel memory footprint slightly, which is not usually an issue on pretty beefy servers that run a lot of containers. But having those values default to a low value is good for all of the more smaller footprint embedded type systems. So that's why the value is low, but in those kind of environments, it's safe to increase them. So that's the sysctls and the security limits that you should be increasing. The other thing, which is under the security section, is if you want to further prevent leakage between containers, you will probably also want to run those too. So those will prevent access to proc get debug and syskernel slab on the entire system. That's also going to propagate to containers. And those two files are not particularly dangerous in by themselves, other than it allows for a container reading that file to figure out what all the other containers on the systems are. So if you're naming your container after, say, a customer name or anything sensitive like that, you'll want to do that just to avoid accidentally leaking information across your system. All right, so that's most of the host configuration bits. Now there's some amount of LXD configuration. The first thing that will come to mind is, well, what kind of storage driver are you going to be using? That kind of default these days for local storage tends to be use ZFS. That's the most reliable, most featureful backend we support. It's not always an option for everyone else. For everyone, the second option for local storage would probably be BurFS. Now, what you need to keep in mind there is kind of what your needs are. If you're going to be running instances for running untrusted workloads or for a bunch of random people, you're going to need something that does quotas properly. So BurFS is pretty much out of the running already. If you need to be able to do fast snapshots and backups and those kind of things, then that's going to be eliminating some of the other options like LVM or directory. And that's why you pretty quickly end up with, well, ZFS is kind of the way to go. The main restriction that ZFS has compared to BurFS is that it doesn't let you easily do nested subvolumes. Even though that feature has landed upstream, we're gonna need to have it be in a major ZFS release and then in Linux distros before we can really make use of that in LXD. So that one limitation is actually gonna go away soon, but it's still there. Other than that, the only real reason not to use ZFS is if your distro doesn't support it, then you will have to use something else. Again, for local storage, usually BurFS would be the alternative, but if you do need strong quotas, then you're probably gonna want to do LVM instead. LVM comes with quite expensive backups and migration, but that's you can have to pick your poison at that point. So that's the storage side of it for production environments. Then the next one would be networking. And for networking, there are kind of two options really. Bridge networking or oven is pretty much what you're going to be using for most production environments, unless you're doing something pretty special where you need to use pre-existing physical networking, whether it's SRIOV or it's like a pre-existing bridge or using MAC-VLAN, MAC-VTAP. So most people are going to be using the bridge network realistically. And there are a number of options that you can use to make that safer. can see that you can apply some amount of security ACLs, which lets you apply some firewalling. So you can use that across the entire network to block to globally block specific ports or addresses you don't want to allow, as well as potentially use address specific rules in there. The other thing you can do on the networking side, but that's actually on the network device side. So if you go in instances and we go look at the bridge network device, you'll see that not only can you limit the network speed, which is potentially quite useful with those limits to avoid a given instance potentially running you out of CPU or network throughput. The other thing you can set is security MAC filtering, IPv4 filtering, IPv6 filtering. Those effectively prevent any kind of MAC spoofing or IP address spoofing across the bridge. So if you're dealing with a shared bridge and you're giving access to different people to instances running on that bridge, it's probably worth setting those as well in a production environment. Now, back to general networking, the other option you can go with is Oven. Oven is very featureful, supports a lot of options, and is especially interesting because it lets you actually create as many networks as you want without any kind of conflicts whatsoever across even LXD projects. So it's really, really flexible, but it's very unlikely to be your option for just a single server. Oven is something you're gonna want to consider if you're running a reasonably large scale cluster, and if you're running that cluster on physical hardware or in an environment where you control the underlying network. Oven doesn't work very well in the cloud, for example, so you probably don't want to use it there. Okay, so that's kind of the networking side of things. Now back to instances. We went through what to do with the networking side in those settings. Still keeping with devices, the other thing you probably want to do is under the disk device is, set a quota. So you can change the size property. And for VMs, you might want to set the size.state. They defaults to 0, so it's less of an issue. But if you want to allow your users to do some amount of live migration and stateful snapshots, you're going to want to set size.state as well. With that done, the other thing you're going to want to do for instances for sure is going to be just applying some limits. So you can apply CPU and memory limits. That tends to be kind of default, but you also might want to set some amount of the priorities, which are particularly useful in more busy environments to just set, who gets to actually have whatever limited amount of CPU or memory you have. It's worth noting that the limits for disk priority, as well as the IO limits for disks in general, don't really work these days. That's because of the transition from most Linux distributions to using a more recent SCSI stack that doesn't support a scheduler that lets you do IO control, as well as now the prevalence of NVMe storage, which doesn't do any kind of OS side queuing, but instead does hardware queuing. So there is effectively no way to slow down IOs or to give any kind of priority on those systems. It's unfortunate, but currently there's just no better options there. So apply limits on your instances. That's obviously quite useful. The other thing, and if you watched my security video recently, you're probably gonna know what I'm gonna be saying, which is on a shared environment, not only do you never want to use security privileged, but you will probably want to use security ID map isolated. So just make sure all your instances have it set, and that means that all instances will have their own chunk of UID and GID space and no overlap whatsoever there. If an instance needs more than what it currently has, you can increase the security ID map size on that one instance, and after a restart, it will have an increased UID and GID range. All right, and the other thing that's quite critical, I think, to a production environment, especially if it's going to be shared in some way, is going to be the use of projects. You can create a project per user, you can create a project per application, whatever makes the most sense for you. And then you can delegate access to that particular project, which is particularly convenient. Now, the trick here is going to be to also configure your project properly. By default, the project doesn't have any limits or any restrictions. So that can make abuse pretty easy. If you're going to be running, either giving access to a third party or running mostly interested workloads or something like that instead of a project, you probably want to actually set project limits. and you will probably want to set restrictions as well. The restrictions can be lifted pretty granularly, so you can allow what you want. It's like some of those are quite unsafe to enable, but if you once you understand the workload, understand the use case, then allow that and don't allow the rest, and that's gonna at least really contain the potential damage. All right. Another aspect of it for a production system would probably be firewalling. So if you're running in the cloud, not usually a huge deal because you can control that through the cloud APIs usually more than the local system. But if you're on a more traditional server and you need to do local firewalling, then you just need to keep in mind that a bunch of the firewalling options have a tendency to interfere with LXD, and you might need to configure them a bit. So there's here a how to configure your firewall, which goes through kind of how LXD works as far as firewalling, but also some of the usual breakage we see. For example, if you use UFW on your system, you might need some extra rules to make LXD keep working. And similarly, if you're also running Docker on your system, you're probably gonna have a bad day as far as networking. You need to do some bit of tweaking there too to make LXD happy. So that's something to keep in mind. Again, as far as firewalling, LXD itself supports something called network ACLs, which if used with Oven is very granular and you can set it on like per instance, per port type basis. If run on top of a normal bridge, then you can apply one ACL for the entire bridge and you need to do IP filtering in there. But that is all doable through the LXD API, so that can be pretty useful to just keep everything in one place. And lastly would be monitoring. So that's another thing that's quite important to production environments. LXD supports two things there. It supports using Prometheus. Well, it has a metrics API, which is usually consumed from Prometheus, but you can consume it from something else, to pull specific instance metrics. And so if you just look for metrics and we go to instance metrics, here we go. This describes how to configure Prometheus to grab those metrics from LXD, kind of the general scraping logic, and all of the metrics that LXD provides. The way this usually looks like, if we go look at my own dashboard, which I need to authenticate on, and again. Okay, so if we go look at, I think it's here, yeah, LXD dashboard, then that gets you something kind of like that. So you can see your overall cluster state. So in this case, for the entirety of the project, which is my core project on my Montreal Data Center cluster, you get to see CPU usage, memory usage, all of that kind of stuff. You can set alerts through Grafana, which is particularly useful. So if you see anything unusual as far as network consumption or anything, you can set it there. And then you can get per instance details, which again, you can set alerts on if you want to. So it's very useful. You could easily set an alert on network errors and drop rates, for example, to see anything wrong with the network. You could set alerts on excessive traffic or I/O, or even CPU, number of processes. Like if you could set in this case that 30 processes is about normal. If I see 50 or more, I want to get an alert because something really weird is going on there. So you can do those kind of things. The Prometheus support in LXD is really useful for that. Now, the other thing we've added very recently is support for Grafana Loki. And this is covered, I believe, in the server settings. Yeah, so here we've got a number of configuration keys for Loki. And this is effectively a log aggregator with support for pretty fancy log parsing and alerting on it. So you can run a Loki server, configure LXD to point to that, and it will stream its logs, and you can configure exactly what you want, like what kind of log level, what kind of event you want. And that will then get you a full timeline. You can also set up alerts on for anything weird going on. LXD supports streaming two different things. Lifecycle events are things like instance started, stopped, restarted, exec sessions, that kind of stuff. And logging are actual built-in logging events. you can choose the log level for logging. By default, we do info, but you could go all the way down to debug. I would not recommend doing that. That would be very, very verbose. And yeah, that's pretty much it on the monitoring side. That should get you everything kind of centrally into your monitoring stack, and then you can have something like a Grafana dashboard accessing both Prometheus and Loki and getting you like a nice overview of what's going on. I would usually combine that with additional data, so something like Node Exporter or Telegraph running on the host system to get general host data as well into something like Prometheus, into those kind of dashboards. And I would also, if I'm in charge of network, also have an SNMP probe in Prometheus that will pull data from the switches so that you can get your port and error rate on your actual physical network, and you can easily identify if any of your specific hosts are using way more bandwidth than they're supposed to. In the case of my own dashboard, I also pull IPMI data from the server, so I can get things like the fan speed, current temperature, and that kind of stuff, power consumption, to see if there's anything unusual going on the systems. Everything feeds into Grafana, and then you can put alerts and decide where it, like how it's gonna alert you. In my case, it's sending me private messages through Telegram right now, which was the easiest approach, but there are many, many alternatives. Like if you're a Slack user, you can have it go to Slack, you can do all that kind of stuff. All right, I realized this was not a very, very technical video and that I didn't really do any demos or anything. It was mostly going through our documentation and kind of covering a bunch of topics. But I think that was, hopefully that was useful to some of you. And that's gonna, like, if you're, whether you're running a partition server already or you're looking at doing running one of those in the future, that was hopefully a bunch of useful pointers for that. And if you've got any questions, feel free to leave them down below, or I think in this case, better yet, go on our community forum and post there, like explain your use case, explain what you're trying to say, what you're trying to do. And we have community members who are have deployed some pretty large scale LXD that are going to be quite happy to help you with whatever you have, or the LXD team will also help you out. So again, hope this was useful to you. I see you in the next video.